Welcome to this explainer. Today we're diving into one of the absolute most high-stakes engineering projects happening on the planet right now, India's Gaganyaan mission. But here's the thing. Getting to space, that's really only half the battle. Bringing humans back to Earth safely, well, that requires a mind-blowing level of precision. So let's unpack a massive breaking development from ISRO that just brought India's indigenous human spaceflight one huge step closer to reality. So how exactly will ISRO safely bring India's astronauts back to Earth? Honestly, this is the central problem of human space exploration. Picture this. When a spacecraft re-enters the Earth's atmosphere, it's traveling at blistering, unbelievable speeds. The friction generates intense heat, and the sheer aerodynamic forces, they're just brutal. If even a single parachute fails, or if the deployment sequence is off by just a tiny fraction of a second, the consequences for the astronauts inside that crew module would be catastrophic. Before you even think about putting a human being inside that capsule, you have to prove, without a shadow of a doubt, that your recovery systems are absolutely flawless.
Which brings us to Section 1, the Human as Spaceflight Challenge.
Take a look at this. What you're seeing here is the July 3rd ground test of a brand new piece of technology at the Satish Dhawan Space Center in Sriharikota, specifically at their static test facility. Think of this horizontal structure right here as a sort of practice rocket. See, ISRO isn't going to use a massive, incredibly expensive full launch vehicle just to test parachutes. That doesn't make sense. Instead, they built a dedicated, highly specialized platform just for testing the safety mechanisms that will eventually bring our Gaganyaan astronauts home. This captures the very first successful ground test of this motor, a massive milestone that's been making headlines everywhere.
All right, let's move into Section 2, introducing the Solve platform.
So, what exactly is SOLVE? If you're studying for competitive exams or just taking notes, definitely write this acronym down. SOLVE stands for the Suborbital Launch Vehicle for Experiments. Basically, it's a solid motor-based test platform. Its entire reason for existing is to validate the deceleration system of the Gaganyaan crew module. In plain English, it is a custom-built rocket designed specifically to carry a dummy crew module high up into the sky and drop it, allowing ISRO to conduct integrated parachute tests under various highly controlled conditions. It's kind of like a really advanced simulator for the parachute system, making sure that when the real mission happens, those parachutes know exactly what to do. Now, take a look at the engineering lineage here. ISRO didn't just invent Solve out of thin air, right? They brilliantly adapted existing proven technology. The solid stage of Solve is actually derived from the famous PSLV strap-on motor. But, they couldn't just use it exactly as is. To meet the very specific requirements of the Gaganyaan test, they had to make some pretty heavy modifications. First, they developed a slow burn rate propellant. This is absolutely crucial because it alters the acceleration and flight profile to perfectly mimic an abort scenario or an atmospheric re-entry. They also gave it a straight nozzle and added secondary injection thrust vector control. What that means is engineers can now steer and stabilize this rocket with unbelievable precision during those critical suborbital test flights. It's honestly a masterclass in taking reliable tech and adapting it for a brand new, super specific purpose. And the results of that July 3rd test? Well, ISRO reported that the motor performance parameters were exactly as expected, a total success. Which leads us right to this quote from the space agency. The development of the SOLVE vehicle provides flexibility in conducting Gaganyaan test missions simulating various conditions. That one word right there, flexibility, is everything. By having their own dedicated modified practice rocket, ISRO doesn't have to wait around for major launch windows. They can repeatedly simulate different altitudes, different speeds, and all sorts of emergency abort scenarios to guarantee those parachutes will deploy safely no matter what goes wrong. Okay, let's break down how this actually works in Section 3, engineering the parachute test. I want you to really picture the sheer drama of this sequence, okay? This is exactly what the SOLVE vehicle is built to do. Step 1, the SOLVE rocket launches, carrying the crew module to an altitude of 10 to 17 kilometers. That is way up in the stratosphere, literally higher than commercial airplanes fly. Step 2, at that critical altitude, the module forcefully separates from the launch vehicle, simulating a return to Earth or an emergency abort. Now it's in free fall. Step 3, and this is where the magic really happens. It doesn't just pop open one parachute. No way. It deploys a complex, carefully timed series of 10 different parachutes. This staged deployment is designed to gradually and safely rip the speed away from the heavy capsule, reducing its velocity so the astronauts aren't crushed by the intense G-forces of sudden deceleration. And finally, Step 4, the crew module achieves a gentle splashdown in the sea, ready for recovery teams. Testing this precise, high-stakes sequence is exactly why SOLVE was created in the first place. Next up, Section 4, Astronaut Readiness and Training. Take a look at these recent Gaganyaan milestones. You see, the SOLVE test is just one part of a massive, synchronized national effort. Alongside SOLVE, ISRO also recently completed the Integrated Airdrop Test, or IAD-20, which is another key parachute validation. But check out the second point, because this is fascinating. Mission Mitra, which stands for Mapping of Interoperable Traits and Response Assessment. This didn't happen in a sterile lab or a space center. This took place in Leh, high up in the Himalayas. Over the past few months, the 4 Indian astronauts selected for the Gaganyaan mission, along with a team of scientists, engineers, and medical professionals, went through a rigorous week-long behavioral study in this extreme, high-altitude environment. They're actively studying how these astronauts react, both psychologically and physically, to isolation and harsh conditions. It's a perfect demonstration of how validating this massive hardware is happening side by side with the intense preparation of the human mind and body.
And that brings us to our final section, Section 5, One Step Closer.
Every successful test brings India closer to its first indigenous human spaceflight. The successful firing of the SOLVE motor on July 3rd isn't just a cool engineering milestone, it's a promise. It proves that India is systematically, safely, and indigenously mastering the absolute most complex challenge of space exploration, bringing our people home safely. For all you students, researchers, and space enthusiasts watching this, it's a powerful reminder that space isn't just conquered with grand, fiery launches. It's conquered through the meticulous, quiet perfection of safety systems, parachutes, and practice rockets like SOLVE. So, I want to leave you with this thought on our final slide. As ISRO perfects the science of bringing astronauts safely home, what new frontiers will India conquer next? The Gaganyaan mission is truly just the beginning. The systems being validated by the SOLVE platform today, they're going to be the foundation for space stations, lunar landings, and deep space exploration tomorrow. I hope this explainer helped you really grasp the incredible engineering behind ISRO's latest achievement. Keep looking up, keep asking those big questions, and I'll see you in the next explainer.